Hi guys, it is time for the lesson on section 7.4, properties of logarithms. Okay, so quick question, what is a logarithm? Are you thinking? Okay, hopefully you remembered that a logarithm is a power or an exponent, and so today we're going to do some properties of logarithms, and they are related to some properties that you already know, and those are exponent properties. So properties of exponents. So over here I'm just going to remind you of those properties. There's a product property for exponents that says if you have the same base, let's say you have a base b raised to the m power, and you're multiplying it times the same base to a different power, like that, well, all you have to do is add those two powers. Like, for example, if we have 5 squared times 5 to the third, we can just add the 2 and the 3, and that's the same thing as 5 to the fifth. So this is the same thing as b, that same base, to the m plus n power. We would add the two powers. So what I want you to see there is that when you're multiplying like bases, you actually add the powers. So then look over here at the power of logarithms. It's called the product property of logarithms. We're taking the log of a product. Product means multiply, and these are multiplied. So anytime they're right up next to each other with no operation in the middle, they're multiplied. So this is a product. Well, we can separate that product with an addition in between. We can take the log of the first one and add it to the log of the second one. So it's log of m plus log of n. So multiplication is related to addition when you're talking powers. So I did an example here. This is the log base 2 of this product. This is a product. So that could also be written log base 2 of 32, because that product could be multiplied out. Well, you can separate that, or what they call it expanding it, by taking the log of the first one and adding it to the log of the second one. So to expand a product, you put a plus in the middle. It becomes an addition problem. Okay, let's talk quotients. There's a quotient property of powers that says this. That says if you have a base raised to a power and you divide it by the same base raised to a different power, well, just like multiplying became an addition problem, we added the powers, division is going to become a subtraction problem. So you keep that same base and you subtract the powers, m minus n. So if it's multiplication, you add the powers. If it's division, you subtract the powers. So I say all that to look at the quotient property of logarithms. So this one, they're taking the log of a quotient or a division problem. So this is a quotient. Quotient just means it's division. Well, you can expand that, you can separate it by taking the log of the top and subtracting the log of the bottom. So it becomes log of m, which is log of the top, minus log of n, which is the bottom. And then the last, here's an example with numbers. Log base 2 of this quotient. I separated it with a subtraction. So log of the top, log of 32, minus log of the bottom, log of 2. Okay, the last property with powers that I want to talk about, or exponents that I want to talk about, is that rule about whenever you have a power raised to another power, power to a power, you multiply them. Power to a power, multiply. So this is the same thing as p to the m times n. Power to a power, multiply. So here we have the log of n to the x. So that's like having a power to a power, and you multiply. So here's what that means. It means you can bring that power that's up in the air, you can bring it down to the front and put it here, and that becomes multiplication. It's x times log base b of n. So see, we had a power to a power, but we're going to multiply. So we bring it down to the front, and that's going to be multiplied. So here's an example with numbers. We have a log of a power, log of a number raised to a power. So it looks like a power to a power, and then we're going to multiply. And the 5 comes to the front. This is the most important one, because this is going to be how we're going to solve equations. See, the whole point of doing logarithms is to be able to solve equations like this. Log base 2 of, no, sorry, I was solving it already, is to be able to solve problems like this. 2 raised to the x equals some number. So it's, the whole purpose is to solve equations that have variables up here in the power. So that's the whole point. All right, so these are some just algebra rules about exponents, and those are related to these rules about logarithms, because logarithms are exponents. Okay, so in this section, we're gonna do these problems forwards and backwards. So we're gonna take ones that are joined together, and we're gonna expand them out, and we're gonna take ones that are expanded out, and we're gonna join them back together. So it says expand this logarithm. So here's what we've got. We've got a product here. Because this is 7 times b, there's no operation in the middle. And whenever you have a product and you want to separate it, we're going to use this product property to separate it out like this. So we take the log of the first one and we add it to the log of the second one, like that. And if at any time you want to pause and then try some on your own and then press play again, that would be a good idea. So this is the log base 10. Since this is a base 10, we actually don't have to have that little number written down there because it's a common log. We're doing the log base 10 of this. This is a quotient. And so to separate a quotient, you're going to separate it with subtraction. Log base 10 of y minus log base 10 of 3. And again, you can leave off the 10s and you can just have log of y minus log of 3, because common logs, the base 10, you don't actually have to write the little base. So if you ever see it written without the base number, that just means it's base 10, it's common log. Okay, this one, it's a power to a power. So we're going to use the power property. So this is a power, so we're going to bring that power to the front, and this expanded is 3 log base 7 of a. That's how you read that, log base 7 of a. Let me fix that. So anytime you have a number up in the air, a little power, and they tell you to expand it, you can bring it down to the front. And this one, it doesn't look very expanded, but it is. So this one, product is expanded with a plus, quotient is expanded with a minus. Whenever you have a power, you bring that to the front, and that's considered expanded. Okay, this one is where they get a little complicated, because we've got two things happening. This is a product, 3 times r to the 4th, but r to the 4th is a power. So we're going to use the product property and the power property to expand this. So first thing I'm going to do is separate this product. So I'm gonna go log base 10 of 3 plus log base 10 of r to the 4th. And I'm just leaving off the base 10 because anytime it's base 10, you don't have to write the little base number. And then we've got a power here that can be brought down to the front. So we've got log of 3 plus 4 log of r. So it's a little more complicated when we have more things happening. So since both things are happening, we have a product and we have this power, we separated it with a plus and we brought that power down. Okay, that's called expanding. So products you expand with a plus, quotients you expand with a subtract, powers in the air you bring them down to the front. All right, so now we're gonna go backwards. It's already expanded, we're just gonna bring it back together. So the directions are to write it as a single logarithm. That just means go backwards and bring it back. Okay, so if you have a minus, that means it's a quotient, which is a division problem. So see, products become pluses, quotients become minuses. So if we're going backwards, the minus problem, the subtraction, became a quotient. So we're gonna write the quotient of 20 and 5, and we get, the answer is log base 3 of 15. I lied. It's log base 3 of 4, because remember I'm dividing the 20 by 5. I'm not subtracting 20 minus 5 like I almost did. I'm dividing, because that subtraction, when you bring it back, you bring it together with a quotient. This can be evaluated, by the way, but they didn't ask us to. If they ask you to, you can evaluate it like we did last class. This is going to be ugly though, because there's no power of 3 that gives you 4, no nice power of 3 that gives you 4. So log of 4 divided by log of 3. Always be careful to close that parenthesis right there. So that's what we would put if they had asked us to evaluate it, but they didn't. They just said write it as a single logarithm, so that's our answer. I think I should circle these answers because I have a lot written here. Okay. So this would be a good place to pause the video and try this one. There's a plus in the middle. So when I bring it back together, I'm going to bring it back with a product. Product means multiply these. So you do not add the 10 and the 5 and get 15. You multiply the 10 and the 5. So this is log base 2 of 50. And again, if they asked you to evaluate that, you could just punch it in a calculator and evaluate it. Okay. On the back, we have two things happening. We have this number in the front, which means it's a power, and we have this subtraction, which means it's a quotient. So, you know how a power we bring to the front? Well, we're just going to put it back. So we're going to take that number 3 from the front and we're going to put it back on the x. So it's log base 2 of x to the 3rd minus log base 2 of y. And then we're going to bring this subtraction together with a quotient. So this gets divided by this. Remember, we're writing it as a single logarithm. So only write the log once. X third divided by y. X third divide by y. Like that. Sometimes people write that in parentheses, and that would be okay too. Like log base 2 of x third over y, like that. That's not a bad idea. I would accept it like this. Okay, now we're going to use the properties and we're going to evaluate it. So kind of like I was talking about on this problem. So we're going to use the property to bring it together, and then we're going to evaluate. You could just evaluate it like it is. You can punch that one in, and you get 4, and you can punch this one in, and you get 2, and then you can go 4 minus 2. But they want us to use the property first. So we should do what the directions say. This, we're going to bring it together with a quotient. So it's a single logarithm, log base 2, of not 16 minus 4, but 16 divide by 4. 16 divided by 4. That right there is just a 4. Log base 2 of 4. If you want to do this without a calculator, just think about what this means. It means 2 to what power would give you 4, and 2 to the second power gives you 4. So the answer is 2. But if you don't want to think that much, your calculator does it. Log of 4 divided by log of 2. 2. And then the last one, it says use the properties. So I have to bring these together, and then I'm going to evaluate. So I'm going to bring them together with a quotient. So I bring those two logarithms together to be one logarithm. And then we're going to divide the 9 divide by the 24. And then they want us to evaluate this. So since this is a fraction, you can reduce that fraction if you want to, but I'm going to use change of base formula. So I'm going to do log of this big number divide by log of this little number. Here's what I'm typing into the calculator. Log of 9/24 divide by log of 6. So this is what I'm going to type in. Just make sure you close parentheses. Oops, not tangent. Log of 9/24 divide by log of 6. And you get, let me make sure I do that right. Log, sorry, my dog is distracting me. 9/24, that's the top. And then divide it by log 6. Yep, you get this answer right here. Negative 0.547. That's what I'm going to put. It's pretty typical to, on ugly answers to logarithms, to put 3, and some books say 4, but I think our current book says 3 decimal places for the logarithm. All right, if you want to check this, remember that's a power. When you answer a logarithm, that's a power, and it's a power of this base. So you can raise 6 to the negative 0.0547 power, and you get this answer, 0.9066. And if you do 9/24, you get that same answer. Hold on. 6 raised to the negative 0.547 power, 0.375, and then 9 divided by 24, it reduced it the last time, but it gives you that same power, 0.375 power. It's a little bit off just because I rounded. So that's just a way to check it. But your calculator will evaluate these for you once you bring them together into a single logarithm. All right, so that is all to that lesson. It's just using the properties to expand logs and to bring logs together. All right, that's all for lesson 7.4. Y'all have a great day. Bye.